Hi, everyone, welcome to my channel again. Today, I am going to share about measurement system analysis. Before watching, please like, comment and subscribe to my channel. Today manufacturing companies gather massive amounts of information through measurement and inspection. If there are errors in our measurement system, we will be making decisions based on incorrect data. We could be making incorrect decisions or producing non-conforming parts. A properly planned and executed measurement system analysis (MSA) can help build a strong foundation for any data-based decision-making process. Process owners should ask themselves the following questions to better understand the capability of the measurement system for a particular CTQ to deliver the information needed for making process improvement decisions. Is the measurement system capturing the correct data? How big is the measurement error? Can we detect process changes when they occur? What are the sources of measurement error, such as inspectors, gauges? Is the measurement system stable over time? What is a measurement system? Measurement system is the collection of gauges, standards, operations, methods, fixtures, software, personnel, environment and assumptions used to quantify a unit of measure to the feature characteristic being measured. What is gauge? Gauge is any device used to obtain measurements such as a caliper, dial gauge, micrometer, optical inspection machine and go/no-go devices. Why use MSA? First is to assess whether the instrument or gauge is capable in terms of precision and accuracy. Accuracy is the closeness of agreement to the true value or to an accepted reference value, while precision is the closeness of repeated readings for each other. Secondly is to determine how much of the total observed variation is due to the measurement variation. Total process variation is broken into two sources. First is part-to-part variation. Part-to-part variation is the variability in measurements across different parts. Ideally, differences between parts or part-to-part should explain most of the variability. Second is measurement system variation. Measurement system variation is all variation associated with a measurement process. Potential sources of variation include gauges, standards, procedures, software, environmental, appraiser and so on. When to use MSA? 1. A criterion to accept new measuring equipment. 2. A comparison of one measuring device against another. 3. A basis for evaluating a gauge suspected of being deficient. 4. A comparison for measuring equipment before and after repair. What is a good measurement system? Fundamental properties that define a good measurement system are included as below. 1. Adequate discrimination and sensitivity. Discrimination is the smallest scale unit of measure. The increments of measure should be small relative to the process variation or specification limits for the purpose of measurement. A general rule of thumb is the measuring instrument discrimination ought to be at least 1/10 of the tolerance spread. Recently, the industry is drive for discrimination is at least 1/10 of total process Six Sigma standard variation. 2. The measurement system ought to be in statistical control. Under repeatable conditions, the variation in the measurement system is due to common causes only and not due to special causes. 3. For product control, variability of the measurement system must be small compared to the specification limits. 4. For process control, the variability of the measurement system ought to demonstrate effective resolution and be small compared to manufacturing process variation. Measurement system errors. Measurement system errors can be classified into two categories: accuracy and precision. Accuracy is the closeness of agreement to the true value or to an accepted reference value. Precision is the closeness of repeated readings for each other. Precision is independent of accuracy. That means it is possible to be very precise but not very accurate, and it is also possible to be accurate without being precise. The best quality scientific observations are both accurate and precise. A classic way of demonstrating the difference between precision and accuracy is with a dartboard. Think of the bullseye of a dartboard as the true value. The closer darts land to the bullseye, the more accurate they are. If the darts land close to the bullseye and close together, there is both accuracy and precision as shown in Figure A. If all of the darts land very close together, but far from the bullseye, there is precision, but not accuracy as shown in Figure B. If the darts are all about an equal distance from and spaced equally around the bullseye, there is mathematical accuracy because the average of the darts is in the bullseye. This represents data that is accurate, but not precise as shown in Figure C. If the darts are neither close to the bullseye, nor close to each other, there is neither accuracy, nor precision as shown in Figure D. Accuracy study consists of bias, linearity and stability. Bias is the difference between the observed average measurement and a true value, master value. Bias indicates how accurate the gauge is when compared to a reference value. Linearity is the change of bias with respect to size or the difference of bias throughout the expected operating range of the equipment. Stability is a measure of how the change of bias the system performs over time. Stability is the total variation in the measurements obtained with a measurement system on the same master or parts when measuring a single characteristic over an extended time period. This variation over time is called drift. You can use a control chart to monitor the stability of a measurement process by measuring a master or control part on the same system over time. Precision or measurement system variation consists of repeatability and reproducibility. Repeatability is the variation in measurement obtained with one measurement instrument when used several times by one appraiser while measuring the identical characteristic on the same part. On the other hand, reproducibility is the variation in the average of the measurements made by different appraisers using the same measuring instrument when measuring the identical characteristic on the same part. In conclusion, gauge repeatability and reproducibility, or GR&R, is an estimate of the combined variation of repeatability and reproducibility. In summary, measurement system error can be classified into 5 categories: bias, linearity, stability, repeatability and reproducibility. Measurement systems analysis is a method for determining whether a measurement system is acceptable. A measurement system analysis is a critical component for any quality improvement process. Evaluate your measurement system before using control charts, capability analysis, or other analyses, to prove that your measurement system is accurate and precise, and that your data are reliable. Thanks for watching. Remember to subscribe to my channel. Bye. See you next time.